Good evening, students. Spheres, a solid geometry. Now, what is the definition of a sphere? Now, as per your notes, or simply you can say a sphere is a sphere is a solid figure bounded by a curved surface is called a sphere. A sphere is a solid figure bounded by a curved surface. This is one definition. Or you can say collection of or set of all points in a space which are equidistant from a fixed point is called a sphere. Right, as there are so many definitions are there, or you can define a sphere is a locus of a point which remains at a constant distance from a fixed point, or else the set of all points in three-dimensional space, or you can say space lying the same distance from a given point is called a sphere. Or simply a sphere is a solid figure bounded by a curved surface is called a sphere. Sphere means this one, right? This is called a sphere. Now this is not a circle. What is the difference between a circle and a sphere? Circle and a sphere. Whereas circle is a two-dimensional figure and sphere is a three-dimensional figure or three-dimensional object, you can say. Right? What is the difference between circle and a sphere? The main difference is circle is a two-dimensional object, or you can say figure. Sphere is a three-dimensional object or a sphere. Now what are the examples of a circle? The examples of a circle are, say, bangle. Right? Bangle is an example of a circle. Right? What about the example of a sphere? This is a football. Example of a sphere is a football. Now we can easily find the difference between a circle and a sphere. Right? That means the collection of all points in a space which are in equidistance from a fixed point is called a sphere. And the distance, that equal distance, the equidistance is called radius of the sphere. And the center or fixed point, the center is nothing but a fixed point, right? This is called center of the sphere C, and this is called radius of the radius of the sphere R, right? Both are similar. Some concepts ఎలా ఉంటాయి, circle కి similar concepts ఉంటాయి, right? Remember. Now we know that the center, the fixed point is called a center of a sphere, and the distance is called radius of a sphere. Right? Now, what is the general equation of a sphere? Any second degree equation, any second degree equation in x, y, and z represents a sphere. Right? Any second degree equation in x, y, and z represents a sphere. Now it has to satisfy some conditions. What are the conditions? First condition, second condition, and third condition. There are three conditions are there. First one is coefficient of x square comma y square and z square are equal. Right? The coefficient of x square is equal to the coefficient of y square is equal to the coefficient of z square are same. Right? The second condition is no terms like xy, yz, zx, xy, yz, zx. The product of terms x into y, y into z, z into x. That equation does not contain this type of term. That means product of term should be absent. And third one is nothing but it must be a second degree equation. Right, there are three conditions are there. What is that? A general equation in xyz represents a sphere if it is of second degree equation, and next one is coefficient of x square is equal to coefficient of y square is equal to coefficient of z square, and the next condition is the product of terms should be absent. Xy, yz, zx term should not be there in an equation. Now what is the example? X square plus y square plus z square plus 2x plus 3y plus 4z plus 10 is equal to 0. Yes, this is a second degree equation in x, y and z, right? Now coefficient of x square is 1 here. Coefficient of y square is also 1. Coefficient of z square is also 1. Right, here there are no terms like xy term is not there, yz term is not there, zx term is not there, right? Therefore this equation represents a sphere. Now second example, 2x square plus 2y square plus 2z square is equal to 4, right? Whether this equation represents a sphere or not. Yes, it also, this equation also represents a sphere. Why? Here it is a second degree equation, right? First of all, it is a second degree equation, right? Now second condition is the coefficient of x square is equal to coefficient of y square is equal to coefficient of z square, right? Coefficient of x square, coefficient of y square, coefficient of x square is equal to 2. All are same. Number 3, there is no xy, yz and zx terms, right? Therefore, this equation represents a sphere. Next example is x square plus y square plus z square plus 2x is equal to 0. Whether this represents a equation of a sphere or not. Yes, this equation also represents an equation of a sphere, represents a sphere. Now why? Again you have to check all the conditions. What is the first condition? It is a second degree equation in x, y and z. Yes, it is an equation in second degree equation in x, y and z. First condition is satisfied. Second condition, coefficient of x square is 1, coefficient of y square is 1, coefficient of z square is 1. Therefore all are equal. Second condition is also satisfied. Next, third condition, there is no xy term, yz term, zx term. These are all absent. Therefore, this equation represents an equation of a sphere. Right? What about this one? Suppose x square plus y square is equal to 4. Whether this represents a sphere or not. Now we have to check. First condition, whether it is a second degree equation or not. Yes. Right. Next one, whether coefficient of x square is equal to coefficient of y square is equal to coefficient of z square or not. No. Therefore, this equation does not represent the sphere. That means it is a second degree equation, but it is not a second degree equation in x, y and z. Right? Now, here the coefficient of x square is 1, coefficient of y square is 1 and the coefficient of z square is 0 here. Therefore, this does not represent an equation of a sphere.